Hello guys, welcome back to another video. In this video we will consider an integral from 0 to 1, ln of x, ln of 1 minus x dx. So it is obvious that we should expand one of the functions into a series, which will we will expand this one. So how will it look like? We know that a Taylor series of ln of 1 plus x is just a sum going from n equals 1 to infinity minus 1 to the n minus 1 x to the n over n. And so we will just plug a minus here, and as you can see we will have a minus here, a sum going from n equals 1 to infinity x to the n over n ln of n dx. ln of x, sorry guys. And we need to interchange the summation and the integral sign. How can you do this? Well, let's just write it as of now, and I will tell you why can we do such thing. We can do it because the sum because this sum is uniformly continuous, and therefore we can do such thing. And now let's evaluate the integral. There is a lot of work. Now we need to do partial integration. We will integrate, of course, ln of x, and we will differentiate ln of x. We will get 1 over x, x to the n plus 1 over n plus 1. This will equal minus a sum going from n equals 1 to infinity ln of x times x to the n plus 1 over n plus 1 minus an integral from 0 to 1 x to the n plus 1 over x times 1 over n plus 1 dx. And this one is integrated with respect to 0 and 1. As you can see, when we plug in 1, we will have ln of 1, which is 0, and 0 is just 0, so this is just 0. And this part we can easily evaluate. We will have a sum going from 1 to infinity. I didn't write 1 over n. We will have 1 over n times, here we will have minus 1 over n plus 1 from here. And this integral is just an integral from 0 to 1 x to the n dx. And as you can see, this is easily evaluated. Minus and minus will cancel each other out. We will have a sum running from n equals 1 to infinity 1 over n times n plus 1 squared. And how will we do this? Well, let's see a little trick that we can do. We will add n and subtract n from this sum. And what will we get? Let me show you. We will take this part and this to be the other part. So we will have minus n over n times n plus 1 squared plus a sum going from n equals 1 to infinity n plus 1 over n plus 1 squared. What happens here? These two will cancel each other out, and so we will have a sum going from 1 to infinity minus 1 over n plus 1 squared. What will happen here? We will have a sum going from 1 to infinity. This and this will cancel each other out. We will have 1 over n times n plus 1. And what will happen now? We can rewrite, we will change the summation to go from n equals 2. So we will have to plug here n minus 1 plus 1, which will just give us n. So we will have 1 minus sum of 1 over n squared plus, and we will decompose this sum into a sum going from n equals 1 to k, when we will take a limit as k sorry guys, we will take a limit. We will take a limit as k approaches infinity of 1 over n minus 1 over n plus 1. As you can see, if we expand those two, we will get n plus 1 minus n over n times n plus 1. And we get what we started with. So this is legit. And now what do we get? So this thing looks like a Basel problem. We know that this sum equals pi squared over 6. And we are missing the first term. So let's add that one and subtract that one. So we will have minus a sum going from 1 to infinity, from 2 to infinity, 1 over n squared plus 1 minus 1. Since the first term is 1. And now as you can see, this part will turn into this. And this is just the remainder. Plus, and as you can see, a limit as k goes to infinity. This will turn into 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 up to 1 over k minus 1 minus 1 over k. As you can see, these terms will cancel each other out, and we are left out with what? Just 1 minus 1 over k. And this one will become a sum going from 1 to infinity, 1 over n squared minus 1, plus a limit as k approaches infinity of 1 minus 1 over k. And now this is easy to see what will happen. This is pi squared over 6, so we will have minus pi squared over 6 minus 1, plus limit of this is just 1, so we will have 1 minus pi squared over 6 plus 1, which is just 2 minus pi squared over 6. And this completes the proof. Alright guys, thanks for watching. Like, share, and subscribe if you want to see more of this. And see you in the next video. Bye guys.